In this video, we will discuss a problem from the previous year MAKAUT question 2018 and 19 on the topic series. The question is, test the convergence of the following series. This series. Now, to start the problem, let us consider the given series B summation n equal to 1 to infinity un. See, this is an infinite series. We denote this series by summation n equal to 1 to infinity un, where un is the nth term of the series. Now, we have to write the nth term by looking into the given terms. See here, the first term, second term, third term, each of these terms are in fraction format. So, the nth term must be of fraction type. That means we have to write the numerator and we have to write the denominator. Now, what will be the numerator and what will be the denominator, and how can we write this numerator and denominator from the given terms? See, first we will write the numerators. Here, the numerator of the first term is 6. Numerator of the second term is 8. Numerator of the third term is 10. Each of these have the difference 2. See, the difference between first term and second term is 2, and the difference between second term and third term is 2. That means these terms are in, actually they are in arithmetic progression. Now we know a result that if T1, T2, Tn are in arithmetic progression with common difference D, then the nth term will be Tn equal to A. T1 plus n minus 1 into D, where T1 is the first term. That means if 6 and 10, they are in arithmetic progression with common difference. What is the common difference here? With common difference 2. So in this sequence, what will be the nth term? The nth term will be 6 plus n minus 1 into 2. That means 2n plus 4. That is, the nth term of the numerator of the nth term will be 2n plus 4. Now we have to write the denominator. Now see that there are 3 terms in each of the denominator. Okay. Here we write the denominator. See, the denominators are, the denominator of first term is 1 into 3 into 5. The denominator of the second term is 3 into 5 into 7. The denominator of the third term is 5 into 7 into 9. Now look into the first term of the denominator. That is 1, 3, 5. If you look, you can see that the difference between these two terms 1, 3, 5 are 2. That means the first term of the denominator of nth term will be 1 plus n minus 1 into 2. From where we get this? We get this from this result. Okay. Then the first term of the denominator of nth term will be 2n minus 1. Now we have to write the second term of the denominator of nth term. That means if we observe the second term, they are 3, 5, 7. And also they are in arithmetic progression with common difference 2. How? The difference between 3 and 5 is 2. Difference between 5 and 7 is 2. That is, in this sequence 3, 5, 7, the nth term will be 3 plus n minus 1 into 2. That means 2n plus 1. Now we have to write the third term, and the third term will be 5 plus n minus 1 into 2. See, the third terms are 5, 7, 9. Each are in arithmetic progression with the common difference 2. You can easily see the difference between 5 and 7 is 2. The difference between 7 and 9 is 2. So what will be the third term? 2n plus 3. Therefore, the nth term, the denominator of the nth term, un, will be this 2n just a second. Two n minus 1, 2n plus 1 into 2n plus 3. So this will be the nth term of our given series. Now we erase this for the freshness. Just wait a second. Just make me clear the screen. Now come to the problem. So the nth term of the given problem will be this. This is the nth term of the given series. So write here, this is the nth term, un equal to 2n plus 4 by 2n minus 1 into 2n plus 1 into 2n plus 3. So we have done with the nth term. Now we have to test the convergence of the series. Now students, we know 4 results. Which results? Number 1 is comparison test. Number 2 is ratio test. Number 3 is Rabi's test. And number 4 is Cauchy's root test. So between these 4 tests, which test we will use here? We will use the comparison test. Why students we will use the comparison, students? Because if you notice the nth term, this nth term, the numerator of the nth term is a polynomial of degree 1 and the denominator of the nth term is a polynomial of degree 3. If you multiply these 3 terms, you can see the highest order of the polynomial, highest degree of the polynomial will be n cube, that is 3. So here the degree of the polynomial in numerator is less than the degree of the polynomial in the denominator. That's why we will use comparison test. Now what is the comparison test? Comparison test say this is the limit form of the comparison test. We will use here the limit form of comparison test. Now what is the limit form of the comparison test? What is the statement? The statement says that if summation xn and summation yn are two series of positive terms such that limit n tends to infinity xn by yn equal to L, where L is finite and L must not be equal to 0. Then what we can say? Then the both series summation xn and summation yn will converge or diverge together. This is the statement of the limit form of comparison test. We will use this test here. That says that if xn and yn are two series of positive terms such that limit n tends to infinity xn by yn equal to L, where L is finite and L not equal to 0, then both the series summation xn and yn will converge or diverge together. Now here we need two series. Now students, from the given nth term of the given series, how can we construct another series? See here, now back to the problem. Here un is two n plus 4 by 2n minus 1 into 2n plus 1 into 2n plus 3. What we have said earlier, that the numerator is a polynomial of degree 1 and the denominator is a polynomial of degree 3. Just take the common highest power from the numerator and denominator. Just take the highest power common. Here we take n and the numerator becomes 2 plus 4 by n, and from denominator we can take n cube out and we can write it as this. Now further calculation gives you this. Now un becomes, un is 1 by n square, this. Now we will choose the another series as 1 by n square. The remaining part is 1 by n square and we will choose this as the another series. That means we can write un equal to some vn into 2 plus 4 by n by 2 minus 1 by n into 2 plus 1 by n into 2 plus 3 by n, where Vn is 1 by n square. And from these we can write un by Vn equal to 2 plus 4 by n by 2 minus 1 by n into 2 plus 1 by n into 2 plus 3 by n. Now find the limit of this value. Then limit n tends to infinity un by Vn will be what? 2 by 2 into 2 into 2. Why? Because the limit of 1 by n is 0 when n tends to infinity. Okay, that's why the limit n tends to infinity un by vn becomes this. And further calculation gives this is 1 by 4, which is finite and not equal to 0. Then by the limit comparison test, therefore by limit comparison test, we can say summation un and summation vn, summation un and summation vn converge or diverge together. That means we have to check the convergency of the series summation un. That means the convergency or divergency of the series summation un depends completely upon the series summation vn. Now what is summation vn? Summation vn is none other than summation 1 by n square. Okay, what we have written here, vn is 1 by n square. So summation vn is summation 1 by n square, and here we have to use another result, that is the result of p series. This series is a p series with p equal to 2, and we know that a p series is convergent. What is a p series? P series is of the form summation 1 by n to the power p, and this series is convergent when p is greater than 1. Therefore summation vn, that is summation 1 by n square, is convergent. And therefore by the result of limit comparison test, we can say summation un is also convergent. That means the given series is convergent. That is, the given series is convergent. So this will be the answer. That's it.